everyone, so this is take 3 of the video because it wasn't recording my voice, but I hope you enjoy it. So 4 5 equivalent fractions. I do have some vocabulary words that you should know that you should copy down. One is numerator, one is denominator. Numerator is the top number in a fraction that tells us how many parts of a whole are being considered, and the denominator is the bottom number that tells us how many equal parts are in the whole. Equivalent fractions are fractions that are equal in value. That means that they pretty much, even though they look different, they represent the same space. Okay, so if you take a look at the bottom, it looks like pizza pies. Well, you could have a giant piece that's half of the pizza pie, or you could chop it up into fourths and have 2 pieces, or we could chop it up into 8s and have 4 pieces, and all of those still represent a half of a pie right here. Okay. Now, how did they do that? Well, whatever you do to the numerator, you have to do to the denominator. So what they actually did is, here, they're just multiplying the numerator and the denominator both by 2. And we end up getting 2 over 4. Same thing. Now here, they multiplied by 2 again, and we get 4 eighths. Okay. So to find equivalent fractions, we can either multiply or we actually can divide as well. So in this case, we can multiply both 4 and 6 by 2, the numerator and the denominator, and get 8/12. They still represent the same space. The only difference is your pieces get smaller when you multiply. Okay, and the reason is because we're breaking them apart into smaller pieces here. So 2 of these is actually the same as 1 of these, except over here it's just 1 piece and here it's 2. Okay, so another way to get an equivalent fraction is actually to divide. So we can take 4/6 and we can divide both numerator and denominator by 2, and we get 2/3. Okay, so whatever you do to the numerator, you must do to the denominator, and you'll still have equivalent fractions. They will still mean the same thing. So to find the missing number that makes fractions equivalent, we have to look at the 2 numbers that are either in the numerator or the denominator that are not missing. So in this case, we have the 5 and 20 over here. Here's 5 and here's 20. And we could figure out the rule that is going on between them. So 5 times what gets us 20, or 20 divided by what gets us 5. So 5 times 4 is 20. And whatever I do to the bottom, I have to do to the top. Whatever I do to my denominator, I have to do to my numerator. So 3 times 4 is 12. Okay, so here I'm going to look at the 2 and the 40 because I want to leave my empty box for last. So 2 times what gets us 40? 2 times 20 gets us 40. 4 times 20 will get us 80. So what I want you to do right now is I want you to pause the video. I want you to try these 2 on your own, and then when you hit play again, you'll see me go through them. So over here, 27 divided by what gets us to 9? 27 divided by 3 equals 9. So what number divided by 3 equals 3? 9 divided by 3 equals 3. 4 times what number gets us to 80? 4 times 20 gets us 80. So 5 times 20 is 100. Simplest form, and you've probably heard about simplest form in 5th grade, is when the GCF of the numerator and the denominator is 1. Okay, so what you actually do is you divide until you can't divide by the same number in the numerator and the denominator anymore. So 12 and 16, and you can divide by whatever number you want. So you think of common factors between the 2, 12 and 16. Well, I know that 4 goes into both of them. So let's divide both by 4, and we end up getting 3/4. Can I divide 3 and 4 by the same number? No. So So this is my simplest form. And 12/16 and 3/4, they are equivalent fractions. Okay? 7/10 is kind of tricky because it's already in simplest form. 7 is prime, and 7 and 10 do not have any common factors. Therefore, you can't divide both of them by anything, so their simplest form is indeed 7/10. Okay, try this one on your own, and then hit play to see what we get. 20 divided, and I'm going to go, nope, not 10, by 2. 20 divided by 2, and 48 divided by 2. We get 10 and 24. Well, am I done? No. Is that okay? Sure. 10 divided by 2, we get 5, and 24 divided by 2, we get 12. 5 and 12, no common factors, so 5/12 is the simplest form of 20 over 48. 20/48. Now, some of you guys probably went right ahead, that's 4, and realized that using our divisibility rules that both of these numbers are divisible by 4, and you went ahead and simplified this way and got this, and that's fine as well. Either way works. So what I want you to do is I want you to try these on your own, and you can hit pause, and then when you hit play, I'll put up the answers. So 2 equivalent fractions for each given fraction over here. You can divide or you can multiply. So first I'm going to divide both the top and the bottom by 2. And this actually gets us the simplest form as well, 2/5. And then I'm going to multiply by 2 because there's nothing else I can do here. And I get 8/20ths. All of these fractions here are equivalent. 4/10, 2/5, 8/20ths. They're all equal. Over here I can divide both numerator and denominator by 7 and get 1/2. And 7 is 1/2 of 14. Or I can multiply and get 14 over 28, also 1/2. Okay. To find the missing number, I'm going to look over here, and 7 times 3 is 21, so 2 times 3 is 6. Number 4, 4 times 5 is 20, 15 times 5 is 75. And simplest form, we have to divide either by 2, or you could have went ahead and divided by 4 right away. But I'm just going to keep dividing by 2 because that's easy. Okay, divide by 7, and we get 1/7. And we are done. Hope you got them all right. Okay, so mixed numbers and improper fractions. I need you guys to copy down all of these definitions, and the video may cut me off, and I'll just continue in another one. But the proper fraction is a regular fraction where the numerator is less than the denominator. That means that proper fractions are less than a whole. Improper fractions tell us that the numerator is greater than or equal to the denominator, and improper fractions are equal to or greater than 1. And then we have mixed numbers, which are a whole number with a fraction together. That means we have wholes and parts. Okay, so we can model them by using pictures. And the bottom number, the denominator, tells us how many pieces to split up our wholes into. So in this case, let's take a look. This says split this up into 4. That's what it's telling me. And then shade in 3 pieces. The numerator tells me to shade in 3 pieces. Okay, is that a whole? No, that's less than 1. 1 would be if we shaded in all 4 pieces. Okay, over here, the denominator tells me to split up my whole into 3, and the numerator tells me to shade 1. Also a proper fraction because it's less than 1. If you take a look here, though, we got a mixed number, a whole number, and a fraction. The denominator tells me to split this up into 3 pieces, and they're supposed to be equal. I know I'm not the greatest artist. And 1 whole is actually the same as 3 over 3. Because, let's take a look. If I shade in one piece here, a whole piece, this is 1 whole, that's 3 out of 3 pieces. And then a part, it would be our 2/3. So this one, we have 2 and 5/6. So we need to split this up into 6 pieces, and I'm going to make my life a little easier. Go like this. Each one has 6 pieces, because that's what the denominator tells me. Okay, 2 wholes. 1 whole is 6 over 6, because I have 1 whole, that's this whole entire box, which makes 1. 1 whole is this whole entire box. And then we have a portion. The fraction is a portion. We have 1, 2, 3, 4, 5. Okay. So mixed numbers can also be rewritten as improper fractions. If we take a look at the numerator and the denominators, the shaded parts out of the divided parts is how we would write it as an improper. So let's take a look at this one right here, this example, the one I'm pointing to, this one. Okay, so yes, our denominator still stays the same because all of my boxes are still split into 3. Okay, we still have 3 pieces in each whole, but how many of them are shaded? 1, 2, 3, 4, 5. So 1 and 2/3 as an improper fraction is written as 5/3, and they are exactly the same thing. Okay, so over here, let's see if you could try this one on your own. Pause it, pause me, and then hit play, and you can check. So 6 is still our denominator because our wholes are still split into 6, but let's count up how many pieces we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Whew. 17 over 6, and that is the same as 2 and 5/6. Now, of course, you're not going to draw models all the time. So to convert mixed numbers to improper fractions, I'm going to show you a quick trick. 1, multiply the denominator by the whole number, and then add the numerator to get the new numerator. Your denominators stay the same. And I call this get mad. Get mad. Okay, multiply. 3 times 3 plus 2. So multiply, add, that's M and A. And the denominator, that's D, it stays the same. Multiply, add, denominator. 3 times 3 is 9 plus 2, 11, and the denominator stays the same. Okay, let's try one more together. Let's get mad. 4 times 2 is 8 plus 3, 11. And the denominator is 4. This is our D. Okay, so we're getting mad. All right, what I want you to do is I want you to try the 3 on your own. And when you can pause the video, and I'm actually going to call it quits over here because the video cuts me off after 15 minutes. I'm going to put up the answers on a new video. So look for the second video to see your answers. Okay? Good luck.